let's derive a mathematical formula for the second law of motion. Consider an object of mass m moving along a straight line with an initial velocity u. The uniform application of a constant force F over a time period t accelerates the object to velocity v. Therefore, the initial momentum of the object p1 equals mu. The final momentum p2 equals mv. The change in momentum is p2 minus p1, or mv minus mu, which is equal to m multiplied by v minus u. The rate of change of momentum is directly proportional to m multiplied by v minus u divided by t. Since force is proportional to the rate of change of momentum, the applied force F is directly proportional to m multiplied by v minus u divided by t. In other words, force equals K multiplied by m times v minus u divided by t. That is, K multiplied by mass into acceleration, where the quantity K is a constant of proportionality, and v minus u by t is the acceleration a, or the rate of change of velocity. If K equals 1, F equals ma. In other words, the acceleration produced by an unbalanced force is directly proportional to the net force and inversely proportional to the mass of the object. The second law of motion gives us a method for measuring the force acting on an object as a product of its mass and acceleration. The SI units of mass and acceleration are kilograms and meter per second square, respectively. The unit of force equals Newton. Therefore, from equation 3, 1 Newton equals 1 kilogram meter per second square. Thus, 1 unit of force is defined as the amount of force that produces an acceleration of 1 meter per second squared in an object of 1 kilogram mass. Referring back to equation 3, force equals mass times acceleration. On substituting values, Ft equals mv minus mu. When f equals 0, for whatever time t is taken, v equals u. That is, there is no acceleration. The object will continue moving with uniform velocity u throughout the time t. If u is 0, then v will also be 0. That is, the object will remain at rest. Thus, the expression for the second law of motion can also be used to arrive at the first law of motion.